Page 6 of Math Studies, quadratics. First, they're going to ask us to graph a couple of functions. The function f of x, which is a parabola, 2x squared minus x minus 3. I've already input it into the calculator into y1. And the second function is a line, g of x equals g x plus 1. And I put that into y2. And they say they want to do it for the domain of -3 to 3, and we'll work on that later, but if you don't remember what that means right now, that's okay. So first thing it wants us to do is to graph it and to draw on the grid here. So let's graph it. Just to see what it looks like when you first turn on the calculator, I'm going to turn it to zoom standard, and then I'm going to graph. There we go. There's the parabola, and there is the line, and I'm going to get a few points so that I can make my own graph, I'm going to do second table. Okay, and I'm going to look at the points from x equals -3 to x equals +3 and see which one of those fit on my graph, on my grid. So there is my x-axis, there is my y-axis. I'm going to do my parabola first, which is my blue function. So the parabola has a point -318, but that's off my screen. -27, and that's also off my screen. -10, okay, that one fits. 0, -3, that one fits. 1, -2. And 2, 3. And 3, 12, that's off the screen. Okay. All right, so there's my blue parabola. And then I want to graph my purple line, x plus 1. So some of the points on x plus 1 are -3, -2, just there, and +3, 4. Okay, all right. So that's my graph, and the next thing it wants to do is it wants to state the ranges of f and g on this domain. Remember how I talked about domain, and maybe you don't remember what domain is? Domain means the possible x values for the function, and they defined it to be from -3 to 3. So what I'm going to do is I'm going to draw yellow lines showing where the domain is. So the domain is going to be -3 and 3, and I drew the edges with the yellow highlighter. So what are the values of the blue parabola between -3 and 3? Well, let's see, it's got a vertex, and the vertex, I can't really tell exactly what the vertex is, but I could do second calc minimum, and I could see exactly where the vertex is by moving the cursor first to the left bound, slightly to the left of the vertex, then slightly to the right of the vertex, and then I make my guess. And the minimum value is 0.25, -3.125. So I'm going to write that down right here. 0.25, -3.125. Okay, and let's take a look at the table. And the leftmost value of the blue parabola, it goes off the edge of the screen, but according to the table, it's -3, 18. So I'm going to write that one down here. And the other side, the value would be 3, 12. Remember, when we find the range, what we're looking for is the lowest possible y value, which is negative 3.125, and the highest possible y value, which is either going to be 18 or 12. Which one is it? It would be 18, right? Because 18 is higher between the two. So for the blue parabola, I would say that the range of the f function is going to be between negative 3.125 and the max value would be 18. Okay. Now, what about the g function, which is the purple line? So the g function ranges between negative 3, negative 2, and the max value is 3, 4, so 4. Okay, so those are the ranges of f and g. Now it wants to find the x-coordinates of the points of intersection of the two functions. So we're going to now use second calc intersect. And the first thing we're going to do is we're going to specify that the first curve we're going to intersect is the parabola. And the second curve we're going to intersect is the line. And the guess, we're going to move the cursor closer to the left intersection. And the intersection is negative 1, 0. So this would be C, negative 1, 0. And the other intersection we can find by repeating the process, second calc intersect. First curve, second curve. Now we move the guess toward the other intersection, hit enter, and the intersection is 2, 3. Okay? All right, so that was C. D, on the same axes and for the same domain, draw the graph of the function h of x equals 2x plus 2. So let's put that one in. I'm going to delete this one, and I'm going to put 2x plus 2 in for a new function. Now I'm going to graph. Okay, and so now it wants me to draw the graph of 2x plus 2. Let's get a couple points from second table. It would be this column here because I put it in the y2 position now. And for example, 2 points would be negative 3, negative 4. And another point, let's say 3, 8 is off the screen, 2, 6 is off the screen. 1, 4 would be another point. 1, 4. So the green line would be like that. Okay, and now they want us to solve the equation f of x equals h of x. Okay, and there's a couple ways to do that. They ask us to do it graphically and algebraically. We're going to do it for now just graphically using the calculator, and then eventually we'll do it algebraically for those who want to watch that. Okay, so how do we solve f of x equals h of x? If you put f of x equals h of x, what that means is the x values are the same and the y values are all the same because we set f of x and h of x, which are equal to the y values, equal to each other. So if we have f of x equal to h of x, that's the same thing as doing second calc intersect. So let's try that. Second calc intersect, second calc intersect, which is number 5. And the first curve is the parabola, yes. The second curve is the line, yes. And then we guess, we move the cursor close to the intersection, we hit enter, and our intersection is negative 1, 0. Okay. And then there's another intersection over here. Let's see what that is. Second calc 0. Oh, I'm sorry. It's not second calc 0. It's second calc intersect, which is number 5. First curve, second curve, and we're going to move the cursor closer to the intersection, hit enter, and we end up with 2.5 comma 7. 2.5 comma 7. Okay, so we solved the intersection of the green line with the blue parabola using the calculator. Okay, and now we're going to do F, which is find the coordinates of the point of intersection of the graph of y equals f of x and the line x plus y equals 5. So this is one more line, and the line x plus y equals 5 is not calculator ready, right? We can't just put it into y equals because it doesn't have y equals by itself on the left side. So what we're going to do now is we're going to rearrange this using algebra. So x plus y equals 5. What if we leave y by itself here, move x to the right side by subtracting x from both sides? That'll give us y equals negative x plus 5. So that is the equation of another line. And then we'll clear out this section, and then we'll put in negative x plus 5. Do you see how I put a negative sign before the x? Instead of the subtraction sign, I put negative sign. If you ever have a leading minus sign, you should use the negative sign. So now we'll graph. Okay, and now I'm going to find the intersection of this one and find the intersection of this one. How do I do that? I do second calc intersect. First curve parabola, yes. Second curve negative x plus 5 is a line, yes. And the guess, I'm going to put it closer to the left intersection. And the first intersection is negative 2 comma 7. And the other intersection would be this one here. We'll find it by doing second calc intersect number 5. First curve parabola, second curve line. Then we're going to move our cursor closer to this intersection. And the intersection is 2 comma 3. Okay. So those are 2 points of intersection between the orange line and the blue parabola. And let's move on, and then later I'll come back and I'll show you how to do the part E with algebra. Number 5. The diagram shows the graphs of the functions x squared minus 3 and 6 minus x squared for the values of x between negative 4 and 4. Negative 4 and 4. That's the domain, I guess. Find the coordinates of the points of intersection. Okay, so again, this is pretty easy. You go to y equals. For the first equation, or the first function, we're going to put x squared minus 3, x squared minus 3. And the other one, we're going to put 6 minus x squared, 6 minus x squared. And then we're going to graph them. And then we're going to find the points of intersection. Now we're going to find the points of intersection by doing second calc intersect. First curve, second curve, and the guess, we're going to move it a little bit closer to the left side to get the left intersection point, which turns out to be negative 2.12. And the y value is 1.5. And then we use the repeated procedure. First curve, second curve, guess. And our guess, we're going to move the cursor close to the other intersection. And it's 2.12, positive 2.12, 1.5. Okay, so those are the 2 points of intersection. write down the set of values of x for which f of x is less than g of x. Okay, so let's color code our parabola, shall we? So f of x, we will make it blue, and f of x is this function. G of x, we will make green. Okay, so g of x is green, and f of x is blue. Okay, we know that they intersect at negative 2.12, comma 1.5 and 2.12, comma 1.5. What about the numbers for x which make f of x, which is the blue function, smaller than g of x, which is the green function? So when is blue smaller than green? Well, I think that blue is smaller than green in this interval here. Between the left and the right intersection points, blue is smaller than green, right? So the answer would be between negative 2.12 and 2.12. Between the two. Okay? So between the two limits, negative 2.12 and 2.12, the x value makes the blue parabola less than the green parabola. Okay? That's it for this page. And in the next video, I'm going to show you how to do Part E with algebra.